Modern artificial intelligence often feels like an approaching crisis, but this sudden automation of human ability is the fourth chapter in a familiar 250-year pattern. At the birth of the United States, every piece of clothing, every cleared field, and every constructed building relied entirely on biological power. Power meant human hands, horses, or the flow of a river. This created a hard ceiling. You could only plow a field as long as an animal could walk, and you could only build as fast as a human arm could swing a hammer. With a vast continent to navigate and a population to feed, biology simply could not keep up with the scale of the ambition. To survive, we had to outsource the effort. We had to substitute muscle and bone with mechanical systems that didn't need to sleep. In the late 1700s, massive boilers and iron gears provided the first mechanical substitution for biological effort. Devices like the mechanical loom and the steam locomotive meant that production and travel were no longer limited by the exhaustion of an animal or the direction of the wind. A century later, the focus shifted from replacing raw strength to conquering the limitations of distance and time. Thomas Edison's incandescent bulb allowed factories to operate long past sunset. By artificially illuminating the workspace, we overrode our own biological sleep patterns to maintain production around the clock. Then came Henry Ford's assembly line. By treating the factory itself as a highly structured, moving process, cars became affordable for the public, rapidly expanding city borders into sprawling suburbs. Over 150 years, we successfully outsourced our physical and spatial limitations to machines, maximizing our raw economic output. By the mid-20th century, the primary bottleneck was no longer physical, it was informational. With the arrival of early personal computers, the frontier of substitution shifted towards the processing of invisible information. This chart shows Moore's law. Computing power doubles roughly every 2 years, causing hardware to shrink while its capabilities explode. We used this growth to substitute our capacity for raw mathematical calculation, compressing entire rooms of filing cabinets into a single silicon microchip. Researchers like Geoffrey Hinton have spent decades building artificial neural networks, bridging the gap between digital systems and biological learning. These machine learning models have evolved beyond simple calculation. They evaluate complex environments and make autonomous decisions. Outsourcing our routine thinking is the exact same evolutionary step as mechanizing the textile loom. We are simply applying the substitution to the mind instead of the hand. This timeline shows the complete trajectory of the last 2.5 centuries. We replaced our arms with steam, our legs with locomotives, our calculators with microchips, and now our routine cognition with algorithms. This diagram illustrates the barbell effect. As AI commoditizes routine cognitive tasks, it hollows out the middle of the value spectrum, but at the edges, value concentrates intensely on what machines can't do: human judgment, earned trust, creative direction, and ethical responsibility. It is natural to feel anxious when tools become this capable, but we have successfully managed these exact transitions before. We aren't being replaced. By shedding the burden of routine analysis, we're finally freed and required to focus entirely on what makes us uniquely human.